Okay, so practice test 10, reading section 3, questions 22 through 32. Before we begin, I would just like to point out, so for the reading sections, there's a couple things you need to do, and it's very important. First and foremost, you need to be a reading surgeon. A reading surgeon. Meaning, when going through this text and through these texts, you need to be extremely, extremely picky and detail-oriented. I'm gonna write those down. Picky, detail-oriented. What I've found, doing enough of these, is that the answer is literally always in the text. The answer is always that there is some sentence telling you the right answer, and it is your job to find that sentence, right? The answer to each of these questions is written somewhere here, and it is your job to find it. And that's what I mean by detail-oriented. You have to find the sentence that is giving you the answer. So let me just show you, because I do these beforehand to make sure I get all the right answers, and I understand my thought process behind it and everything. So this is my key that I had, and I'm going to go through everything I did and everything else. But you see, I wrote down the margin notes, exactly where the answers are, what I found. I found the answers over here for these and everything. And this is what my paper looks like before I even tackle any of the questions or try answering anything. So, first things we always do is we always look at the questions first. So let's begin. Based on the passage, textbook authors in the early 1990s would most likely have expected which condition to result from the blocking of fast fibers. So blocking of fast fibers. Textbook authors, early 1990s. Okay. Then these two are connected. Which choice provides the best evidence for the answer to a previous question? Line 18, word active, box active. This is question 24. So we're going to go to 18, line 18, active. 24. Line 24, capture. And that's question 25, capture. 25. Which conclusion is best supported by the findings of Ollison's 1993 experiment? So now I'm going to go through really quickly and skim until I see 1993, I see 1990s, 1993. Right, so we have a 1993 experiment. Okay. Then these are connected. Which choice provides the best evidence for that? Sentence in line 43 to 45. 1, 2, 3, 43 to 45. 28. Question 28 is right here. And it says, but, to mystifying, but, why exact humans might have such fibers which respond only to a narrow range of rather subtle stimuli is initially mystifying. Okay, so that's question 28 right there. Then we have 1990. It can be reasonably inferred that one of the intended goals of 1990 is to determine. Okay, so this is when I start writing things down. So we have the first question was this one, right? So as we're reading, we need to look for certain pieces of information. So we need Olof's 1993 experiment conclusion, right? So when we're reading, once we come across the 1993 experiment, we need to find its conclusion, and that's question 26. And the next thing we need to find out is question 29, which is it can be reasonably inferred one of the intended goals. So intended goals, so we need the goals of the 1999 experiment. All right, this is question 29. And we have main purpose of the sixth paragraph, lines 64 to 75, 64, 75. So that's gonna be question 30. All right, and then over here, I'm just gonna draw main purpose. Cool. Then according to the passage, GL differed from Olson's other test subjects in terms of, all right, so for 31, we need GL's differences from O's other test subjects. So, just doing a quick, I'm going to look for GL, just so I know to pay special attention. GL, 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 GL. Okay, so we know to pay special attention when we come across GLs, right? And we're looking for the difference from the Olafson's other test subjects. Got it. That's question 31. Then lastly, according to the passage, humans experience an emotional aspect of touch when. So we experience emotional, so emo aspect of touch when. Okay, so now I've fully mapped out every single question of what's needed before I even read, right? Oh yeah, and blocking first fibers. We know the 1990s. Blocking fibers. And then blocking fast fibers. That's another one we need. Blocking fast fibers. So I've looked at every other question. I know exactly what we're looking for. I know exactly what I need to pay attention to. I've sent markers for when I need to pay attention. I'm like, oh, this was one of the questions. Ding, ding, ding. Oh, here's another one. So that way we're good. So we are officially ready to start reading. Let's begin. In the early 1990s, textbooks acknowledged that humans had slow conducting nerves, but asserted that those only responded to two types of stimuli, pain and temperature. Pain and temperature, so they had slow conducting nerves that only responded to two types of stimuli, pain and temperature. Sensations of pressure and vibration were believed to travel only along myelinated, fast signaling nerve fibers. So, one of the things we wrote down for the question, for the first question, 22, was fast signaling nerve fibers, so we gotta pay special attention. So sensations of pressure and vibration were believed to travel only along myelinated, fast-serving nerve fibers, which also give information about location. Experiments blocking fast nerve fibers, experiments blocking nerve fibers supported this notion. Okay, I'm just gonna circle blocking nerve fibers. Preventing fast fibers from firing, either by clamping the relevant nerve or by injecting the local anesthetic lidocaine, seemed to eliminate the sensation of pressure altogether. But blocking slow fibers only seemed to reduce sensitivity to warmth or a small painful shock. So blocking slow fibers only, right? But these are slow fibers. We want to talk about fast fibers, preventing fast fibers from firing. So Hakan Olesen and the Gothenburg University colleagues Aki Valbo and Johan Westberg wondered if slow fibers responsive to gentle pressure might be active. You need to know the definition of this word. It might be active in humans as well as in other mammals. So Hakan wondered if slow fibers responsive to gentle pressure might be active in humans as well as in mammals. Okay. So in 1993, they corralled 28 young volunteers and recorded nerve signals while gently brushing the subject's arms with their fingertips. Using a technique called microneurography, in which fine filament is inserted into a single nerve to capture its electrical impulse, the scientists were able to measure how quickly or slowly the nerves fired. Okay, capture here clearly means record. This is how doctors record nerve firings. They insert them into there and see if there's an electrical pulse. So there's that. Scientists were able to measure how quickly or slowly the nerves fired. They showed that soft stroking prompted two different signals, one immediate and one delayed. So soft stroking prompted two different signals, one immediate and one delayed. Now, this is the 1993 experiment, right? So this is what they were able to conclude, because that's what we're looking for, the conclusion of the 1993 experiments. So that is their conclusion, that soft stroking prompted two different signals, one immediate and one delayed. The delay, Olesen explains, means that the signal from a gentle touch on the forearm will reach the brain about half a second later. This delay identified nerve impulses traveling at speeds characteristic of slow, unmyelinated fibers, confirming the presence of these fibers in human hairy skin. Okay, so confirming the presence of these fibers in human hairy skin, and the fibers are slow, unmyelinated fibers. This is also a conclusion, right? They concluded two things, that there's two different signals from gentle stroking, one that's immediate and one that's delayed. One comes half a second later. And then the next one is that they concluded that there's a presence of slow, unmyelinated fibers in human hairy skin. So these are two things that they concluded from the 1993 experiment. Cool. In contrast, fast conducting fibers already known to respond to touch signal at a rate between 35 and 75 meters per second. Then in 1999, goals of the 1999 experiment. So here we are, 1999. So we need to find the goals of this experiment. Then in 1999, the group looked more closely at the characteristic of slow fibers, right? Okay, slow unmyelinated fibers. They named these low threshold nerves C-tactile or CT fibers, said Olesen, because of their exquisite sensitivity to slow, gentle, tactile stimulation, but unresponsive to noxious stimuli like pinpricks. Okay, so all I can tell you right now, I don't know what the answers are looking like, but that answer is going to be right here. All right, it's going to be at this point. Okay, but why, so question 28, but why exactly humans might have such fibers which respond only to a narrow range of rather subtle stimuli was initially mystifying. So why humans might have these fibers which only respond to subtle stimuli is confusing to them. Okay. Unlike other types of sensory nerves, CT fibers could be found only in hairy human skin. CT fibers can only be found in hairy human skin, such as the forearm and thigh. No amount of gentle stroking of hairless skin, such as the palms and soles of the feet, prompted similar activity signatures. Olesen and his colleagues decided that these fibers must be conveying a different dimension of sensory information than fast-conducting fibers. So that sounds important. These fibers must be conveying different dimension of information than fast-conducting fibers, and these are CT fibers. Right? CT fibers. Slow. Gentle tactile stimulation. Although microneurography can give information about how, let's put microneurography here. Right, we circled it here, we have it here. Although microneurography can give information about how a single nerve responds to gentle brushing and pressure, it cannot tease out what aspect of sensation that fiber relays, says Olesen. So microneurography can give you information about how a single nerve responds to, brushing, gentle brushing and pressure, but not tease out what aspect of the sensation that fiber relays. He wanted to know if that same slow nerve can distinguish where the brush touches. Let's write this. He wants to know where if the same slow nerve can distinguish where the brush touches the arm. Whether it can discern the difference between goat hair, brush hair, and a feather. Most importantly, can that same fiber convey a pleasant sensation? Okay, so these are the things he wants to know. These are the things he's trying to figure out. To address the question, Olesen's group sought out a patient known as GL. Oh, gotta pay special attention. GL, different from O's other testing subjects. Okay. So we need to pay attention to how she's different, or they're different from O's other testing subjects. So to address the question, Olesen's group sought out a patient known as GL who had an unusual nerve defect. More than 2 decades earlier, she had developed numbness across many parts of her body after taking penicillin to treat a cough and fever. Okay, so GL developed numbness across the body after taking, that doesn't matter, many parts of the body. Testing showed that she lost responsiveness to pressure, and a nerve biopsy, meaning they cut out a piece of her nerve, confirmed that GL's quick conducting fibers were gone. Okay. So she lost response to pressure and her quick conducting fibers are gone, resulting in an inability to sense any pokes, prods, or pinpricks below her nose. Okay, so she can't feel pokes, prods, or pinpricks below her nose because her fast-firing nerves are all depleted from the penicillin she took. Okay, but she could still sense warmth, suggesting her slow-conducting, unmyelinated fibers were intact. Okay, she could still sense warmth. Upon recruiting GL, Olesen tested her by brushing her arm gently at the speed of between 2 to 10 centimeters per second. She had more trouble distinguishing the direction or pressure of the brush strokes than most subjects, but reported feeling a pleasant sensation. When the researchers tried brushing her palm, where CT fibers are not found, she felt nothing. Okay, so she felt a pleasant sensation. So what this means is that CT fibers equal pleasure, right? Because she brushed it on her palm, felt nothing, but when she brushed it on her arm, she did feel a pleasant sensation, despite the slow ones being gone, her slow nerves being completely gone, which means that the only ones she has left are her fast-moving nerves, and so those ones conduct pleasure. Got it. Olesen used functional MRI studies to examine which areas of the brain lit up when GL's arm was gently brushed to activate the CT fibers. In normal subjects, both somatosensory and insular cortices were activated. So for normal people, both are activated, but only the insular cortex, which processes emotion, okay? So IC processes emotion, was active when researchers brushed her arm. Okay, so here's how she's different, right? GL only has the IC. Her insular cortex is the only thing that activated. It means her somatosensory ones are gone. So that's one way she's different. Also, she's different because she can't feel poking and prodding or pinpricks below her nose. So here's two possible answers right there. And so that one we got there. This solidified the notion that CT fibers convey a more emotional quality of touch. We said CT fibers equals pleasure. So CT fibers convey a more emotional quality of touch, which is also one of the answers. We experience emotional aspect of touch when the CT fibers are activated. So rather than conscious aspect that helps us describe what we are sensing, CT fibers, it seems to specifically provide pleasurable sensations. Wonderful, that's exactly what we wrote. All right, well, here we are. Let's tackle the questions. Oops. Get on my other papers. There we go. Okay. So based on the passage, textbook authors in the early 1990s would most likely have expected which condition to result from blocking of fast fibers. So that was over here, blocking of fast fibers. Fastening nerve fibers. So what are they asking? They're asking if most likely have expected which condition to result from the blocking of fast fibers. A rate at which other nerve fibers fired would increase. Never said anything about an increase in nerve fibers. The test subject would perceive gentle stimulation as painful. It does mention pain and temperature, but not in association with gentle stimuli. Let's leave it for now. The body would compensate by using slow fibers to sense pressure. All right, let's reread this first paragraph. In the early 1990s, textbooks acknowledged that humans had slow conducting nerves, but asserted that those nerves only responded to two types of stimuli, pain and temperature. So they have two types of nerves, and they only respond to pain and temperature. Sensations of pressure and vibration were believed to travel along myelinated, fast, slowing nerves. Okay, so what they're saying is that fast nerves carry vibration and pressure. So if you were to block fast nerves, then the ability to perceive vibrations would be impaired. So yeah, the answer is D. right? Because it literally says right here, sensations of pressure and vibration were believed to travel only along myelinated fast signaling nerve fibers. So if you were to block those, then your sensation of pressure and vibration would be blocked, so the ability to perceive vibration would be impaired. Perfect. Which choice provides the best evidence for the answer to the previous question? Oh, well, we used evidence from line 4 onward. So is there anything from 4 onward? Yes. B. Sensations of pressure and vibration were believed to travel only along myelinated fast-serving fibers, which also gives information about location, which is what B. That was what gave us the answer. That's the sentence we used to inform us, so I'd put that for now. All right, we can look at 1 through 4 in the temperature. In the early 1990s, textbooks allowed humans to respond to the temperature. Nope, nothing about vibration. Lines 12 through 14. Blocking shock. Blocking slow fibers only seem to reduce sensitivity to warmth or a small painful shock. That's slow fibers. We're looking for fast fibers, right? Fast fibers, 34 to 36. In contrast, 7.0. So in contrast, fast conducting fibers are already known to respond to touch signal at a rate between 35 to 37 milliseconds. Okay, let's talk about fast fibers, but it mentions absolutely nothing about vibration. So B is the best answer. All right, as used in line 18, active most nearly means active, line 18. Active, okay. So Hakan Olesen and his G University colleagues AV and JW wondered if slow fibers responsive to gentle pressure might be active in humans as well as in other mammals. So might be restless? No, that makes no sense. Might be movable? No, that makes no sense. Might be attentive or present. Okay, those two both make sense. Let's substitute it back in. So him and his colleagues wondered if slow fibers responsive to gentle pressure might be present in humans as well as in other mammals. Okay, yeah, that makes sense. Okay, him and his colleagues wondered if slow fibers responsive to gentle pressure might be attentive in humans as well as other mammals. Doesn't really make as much sense, but it still makes sense. So let's keep on reading. We have to figure out what they were trying to find out. Right? Because we're trying to, either if it's present, that means that they want to know whether or not those fibers are in humans, or attentive means they just want to figure out whether or not those fibers, they already know that the fibers are in humans, they just want to make sure that they're responsive. It's not like a vestigial structure, which is like another word for some part of evolution that we no longer use. So confirming the presence of these fibers in human hairy skin. Presence, right? Confirming the presence. So that's why I'm going to go with A. They wanted to know whether or not they're present in humans and other mammals. Also, exactly why humans might have such fibers was initially mystifying. So they're confused as to why humans would have these fibers. So that's why they're trying to find out whether or not they're present. Not that they work, they want to know if you have them at all. And they're surprised that they do. Right? Only in hairy human skin. All right, let's move on. As used in line 24, capture most necessarily means capture. Using a technique, we wrote record, which a fine filament is inserted into a single nerve to record its electrical impulses. Record, capture, record. Okay, well, record is one of the answers, so that's perfect. So we can occupy, seize, influence, no, and no. Single nerve, okay. Which conclusion is best supported by the findings of Olesen's 1993 experiment? Okay, so that's over here, right? 1993 experiment, the conclusion. Oh wait, no, over here. So what are they trying to find out? We had the conclusion was that soft stroking prompted two different signals, one immediate and one delayed, and that it confirmed the presence of these these fibers in human hairy skin. Human hairy skin. Okay. So which conclusion is best supported by the findings of Olesen's 1993 experiment? stimulation at bodily extremity can be sensed as rapidly as stimulation closer to the brain. No, we never talked about that. The presence of hairs in human skin lessens the speed at which nerves conduct signals. Okay, maybe. I don't really think we spoke about that, but maybe. Gentle pressure is sensed not only by fast fibers, but also by slow fibers. No, I think the whole point is that, well, no, they do, yeah. Okay, hold on. And the speed at which nerve fibers fire is dependent on the strength of pressure applied to the nerve. Okay, this one's gonna be tough. Let's reread the whole experiment. So they wanted to find out whether these slow fibers responsive to gentle pressure might be active in humans as well as in other mammals. In 1993, they corralled 28 young volunteers, recorded nerve signals while gently brushing the subject's arms with their fingertips. Using a technique called microneurography, in which a fine filament is inserted into a single nerve to capture the electrical impulses, the scientists were able to measure how quickly or slowly the nerve endings fired. Okay. They show that soft stroking prompted 2 different signals, one immediate and one delayed. Okay, so they're testing how quickly the nerves things get fired, and they're testing the pressure. Okay. The delay, O explains, means that the signal from one gentle touch on the forearm will reach the brain about half a second later. This delay identified nerve impulses traveling at speeds characteristic of slow, unmyelinated fibers, about 1 meter/second, confirming the presence of these fibers in human hairy skin. Okay. So which conclusion is best supported by the findings of Olson's 1993 experiment? Stimulation of the body strongly to be sensed as rapidly as stimulation close to the brain. The presence of human hairs and skin lessens speed, which, okay, it says nothing but the speed's getting lessened. Gentle pressure is sensed not only by fast fibers, but also by slow fibers. Well, yeah. It says that there's soft stroking prompted 2 different signals, one immediate and one delayed. And then one was the slow and myelinated fibers, confirming the presence of these in human skin, and the other one's the fast one. So definitely, yeah. But let's look at letter D. The speed at which the nerve fires is dependent on the strength of pressure applied to the nerves. The speed at which the nerve fires is dependent on the pressure. The signal from a gentle touch on the forearm will reach the brain about a half a second later. This delay identified nerve impulse traveling at speeds characteristic of slow, unmyelinated fibers. Soft stroking prompted 2 different signals, one immediate and one delayed. How quickly or slowly the nerves fired. So, this is a tricky one. So which conclusion is best supported by the findings of 1993? I would go with C. Gentle pressure is sensed not only by fast fibers, but also by slow fibers. And that's because we know that there's 2 separate fibers, fast ones and slow ones. And this experiment right here says that that's what was concluded, that there's 2 fibers, that there's an immediate response from one signal and a delayed one. So there's the fast one and the slow one. So we can definitely conclude, confirming the presence of these fibers in human hairy skin. So that's why I go with C. Now the speed at which the nerve fibers is dependent on the strength of the pressure applied to the nerve, it never really says that. Like, I understand it's gentle ones, but they're saying is that the gentle ones fire the slow ones, but they don't activate the fast ones at all. So that means that it's not the speed at which the nerve fires. They don't fire to begin with, or at least half of them. The fast ones don't, or the slow ones. Okay. So the evidence we use, we said it was this line, right? Which is around like 25 or 26 to 28. 26 to 28. But let's look. 26. They show that soft stroking prompted 2 different signals, one immediate and one delayed. Great, that was the evidence we used. All right, sentence in line 43 to 45, but mystifying. But why exactly humans might have such fibers which respond only to our narrow range of rather subtle stimuli was initially mystifying. So this sentence serves mainly to what? Unlike other types of sensory nerves, CT fibers could be found only in hairy human skin. Okay, so identify factors that Olson had previously failed to consider. Well, let's read before. So then in 1999, the group looked more closely at the characteristic of slow fibers in low threshold nerve, C-tactile or CT, because of their exquisite sensitivity to slow, gentle tactile stimulation, but unresponsive to noxious stimuli like pinpricks. Okay. So no, I don't think it has to do anything about, shitting on Olson. Propose a solution to a dilemma encountered by Olson. There's no dilemma. They never mentioned a dilemma. Anticipate a potential criticism of Olson by the reader. Show a problem. No, I don't think the reader or anyone's really trying to criticize him. Show a problem from the perspective of Olson's team. Yeah. So they had a conclusion from their 1990 experiment, but then they're confused as to why humans would even have these fibers. So that makes the most sense. It can reasonably be inferred that one of the intended goals of the 1999 experiment was to determine the 1990 experiment goals. Precise nature of sensations that CT can convey. And then in 1999, the group looked more closely at the characteristic of slow fibers. Okay, so we're looking at characteristic of slow fibers. They named these low threshold nerve CT fibers because of their exquisite sensitivity to slow, gentle tactile stimulation, but unresponsiveness to noxious stimuli like pinpricks. Okay. So the relationship between body hair and CT fibers, they mentioned nothing about body hair in that experiment. Role play by CT fibers in the perception of pain. Okay, they never mentioned pain. So I don't know, but the effect of microneurography on CT fiber signaling. Is microneurography mentioned in this paragraph? No, it's not. So absolutely not. Now, pain is never mentioned, right? But you can extract pain from the noxious stimuli like pinpricks. Well, you don't know if pinpricks are going to be painful. No, they're looking for the characteristic of slow fibers and how they respond to stimulation. So I'm going to go with A. They never mentioned pain. The main purpose of the sixth paragraph, lines 64 to 75 are 64, question 30, okay. Main purpose of this paragraph, to address the question Wilson's group sought out a patient known as GL or an unusual nerve defect. Okay. Identify those of GL's neurological conditions that might be relieved by the experiment. No, she never had anything relieved by the experiment. Contextualize the nerve function of GL by comparing it to that of other adults. Contextualize the nerve function. That doesn't sound right. Let's keep going though. Detail procedures that GI had experienced during previous experiments. Nope. Never really mentioned anything about previous experiments. I know she got tested other times, but it wasn't an experiment. She got tested because she couldn't feel half the stuff. Indicate why GL's medical condition was of value to... Yeah, this is the right one. Right? Because to address the question, they sought out a specific patient known as GL who had an unusual nerve defect. The only reason why they wanted to talk to this person was because of her unusual nerve defect, which shows that they're indicating why her medical condition was one of value for Olson's experiment, right? To address his question that was proposed by his previous experiment. Cool. According to the passage, GL differed from Olson's other test subjects in terms of, okay, how she differed. We said there was two things that she differed. One, the fact that she has a nerve defect, so she can't feel half the stuff. And then two, we said her somatosensory and insular cortex were, only her insular cortex was activated. When for most people, for normal people, they have both the insular cortex and the somatosensory cortices. Okay, so let's look. Number of cortices activated in the brain during gentle brushing. Yeah, we just said that. Her somatosensory ones are not activated. So that looks yes, but let's keep going. Physical dimensions of somatosensory cortex. Nope. It's not that her physical dimensions of it are weird. It's just that it doesn't activate. Intensity of nerve signals required to activate the insular cortex. Nope, her insular cortex is fine. It's the only thing that works for her. The effect of MRI scanning on the basic functions of brain cortices. I mean, they mentioned the functional MRI studies, but it's not about the MRI and how it affects her. It's just about her and how her, again, number of cortices activated in the brain during gentle brushing are not activated. Half of them are missing. All right, cool. A. According to the passage, humans experience an emotional aspect of touch when. Okay, so we said the emotional aspect of touch. So CT fibers convey a more emotional quality of touch. CT fibers specifically provide pleasurable sensations. Okay. So brain cortices are shielded from nerve signals. No. CT fibers are exposed to stimulus. Yes. Literally says it here twice. Nerve fibers that sense pain are suppressed. No, never mentioned, but suppressing fibers. Nerve fibers for pain. Conscious aspects of sensation are ignored. Now we're talking about ignoring sensation. 32B. Okay. Cool.